Good afternoon to all. My name is Sohan Gupta, Assistant Professor in Computer Science Department in Global Institute of Technology, Jaipur. I am teaching a digital image processing in its semester. Today, I am, I am given a lecture on introduction of digital image processing. In this lecture, I am covering the following topics, just like what is DIP, application of DIP, steps in image processing, components of DIP, sampling and quantization, image acquisition, and color image representation. Now we will discuss point to point, and first I will come in what is DIP. So all of you know what is DIP. DIP is a digital image is a representation of a two-dimensional image as a finite set of digital values called pictures, elements, or pixels. All the processing done by digital computer. The attributes are abstract from the image. All the properties of image are abstract here. By using the DIP, we can recognize all the individual objects in image. Then we will come on application of DIP. Digital image processing in many different fields. First, I will discuss in use in office automation. Office automation are used in the form of optical characteristics recognition, documents processing, cursive, script recognition, logo recognition in mostly. And next are desktop publishing. Desktop publishing mostly used in flags making, banner, visiting cards, etc. And next IT industry. In the IT industry, the DIP is mostly used as a image transmission, video text, video conferencing, and video font etc. And entertainment. In the entertainment, SDTV, multimedia, and video editing. Fifth, military application. In the field of military application, it is used as a guide and detect the missile target identified etc. 6. Forecasting. The digital image processing are used in the form of short-term weather forecasting, long-term climate change detection, and cloud pattern. And next, criminology. Criminology uses a fingerprint identification, face recognition and matching, forensic investigation, etc. And last, medical field. In the medical field, in the form of DIPM, we are use ECG, EEG, EMG, X-ray, MRI, UCG, cancer, similars, etc. These are the application of DIP. Now we will come on steps in image processing. In the image processing system, the 11th steps are followed for complete the process of digital image. In the image processing, the first step of image acquisition, first step is the image acquisition. In the image acquisition, it is a first stage of any vision system is to image acquisition stage. After the image has been obtained, various methods of processing can be applied to the image to perform the many different vision tasks. The image acquisition stage involves the pre-processing such as scaling. Second step is image enhancement. It is improvement the perception of information in the image for human viewers. Step number third, the image distortions. Image distortion deal to improve the appearance of an image. To restore an image that is not looking good due to some distortions or noise. This technique is based on mathematical and probabilistic model to image degradations. Fourth steps, color image processing. It is an area that has been gaining the improvement because of significance increase the use of digital image over the internet. Fifth step is wavelets and multi-resolution processing. In this step, we are the foundation of representing the image in various degree of resolutions. Step number 6, compression. Compression is a technique that is used for reducing the storage space, for saving an image and reducing the bandwidth required for transmission of an image. Step number 7, morphological processing. It deals with the tools for extracting image components that are useful for representation and description of a shape. Step number 8 is a segmentation. Segmentation is the process in which images are converted into small segments so that we can extract the more accurate image attributes. Step number 9 is a representation and description. It always allows the output of a segmentation stage, which is usually raw pixel data. And description is also features of selections deal with extracting attributes that result of some quantitative information of interest or are the basic for different form of class to another class. Step number 9 is object recognition. Object recognition is a process that assigns a label to an object based on its descriptors. Step number 11 and last, knowledge base. It is only the base that helps to synchronize all the process to each other. This is a steps for image processing. It's a fundamental steps for image processing. Then next step is components of DI. When we are process of an image for any operation, then we need some components of this process. So we need some 8 components, namely image sensors, image processing software, spliced image processing hardware, hard copy, computer, image display, mass storage and network. These are components which are used for processing an image. First, we are provide a problem domain to image sensors. Image sensor acquire the image, sensing the image and sense the intensity, amplitude, coordinates and other features of an image. And second step is image processing hardware. It is a dedicated hardware that is used to process the instruction obtained from the image sensors. Third step is a computer. It is basically a general purpose personal computer. And fourth step is image processing software. Image processing software is a software that includes all the mechanisms and algorithms that are used for image processing system. Step number 5, mass storage. Mass storage stores the pixels of the image during the processing. Hard copy device. Hard copy device is once the image is processed, then it is stored in the hard copy device. It can be pen drive, laser printer or any external ROM devices. 7th number का है display device. It includes the monitor or display screen that display the processed image. And last, network. Network is the connection of all the above elements in the image processing system. These are the components of DI. Now next topic is sampling and quantization. Sampling is a process of digitizing the coordinates value. It is done on x-axis where infinite values are converted to digital values, as per we can see in the diagram. And second is quantization. Quantization done on y-axis. It is divide the image into quantum form, a partition form. It is digitizing the amplitude or intensity of colors. So that's it. It's a small topic in the PPT in sampling and quantization. And next topic is image acquisition. It is a first step of fundamental image processing system. In this acquisition, the general aim of image acquisition is to transform an optical image into an array of numerical data which could be later manipulated on a computer. In the incoming energy transformed into a voltage by a combination of input electrical power and sensor material energy being detected. There are three methods to acquire an image. First one is single imaging sensor, second sensor strip, and third is array sensor. In the image equation using a single sensor, we will take an example of single sensor as a photodiode. Now to obtain a two-dimensional image using a single sensor, the motion should be in the both x and y direction. The rotation provide motion in one direction only, and linear motion provide motion in the perpendicular direction. And sensor strips, in this arrangement, the sensors in the form of sensor strip, the strips provide imaging elements in one direction only. Sensor strip mounted in a ring configuration are used in medical and industrial imaging to obtain cross-sectional image of 3D object. And image equation using an array sensor is a work as a horizontal and vertical strip work together. Both are horizontal and vertical strips are working parallel. No motion required. It convert hug area of an object and sense the energy without motion. Here we need to bring object just front of it and it is recognized and make very comfortable and no any other need of directions. So it is an image equation. And last topic is color image representation. A color representation is an image of digital image that includes color information of each pixels. A color image has three values per pixels, namely red, green, blue, and they measure the intensity and prominence of light. We can divide color image processing in two parts. First one is full color image processing and second is pseudo color image processing. In the full color image processing, the image acquired with the help of full color sensors. For example, the full color image sensor are the color TV, camera, and color scanners. Basically, it is used in publishing, visualization, and the internet. And pseudo color processing is assigning a color a particular monochrome, intensity, or range of intent. Thank you.